Okay, picture this. It's 1972. A French physicist is staring at a completely routine lab report, looking at a single number on a page. And he thinks to himself, wait, this is actually impossible? That number was a measurement taken from a completely ordinary-looking piece of rock from a mine in West Africa, and it contained a tiny, almost microscopic anomaly. But as you'll see in this explainer, that tiny anomaly ended up unlocking one of the most mind-blowing true stories of deep time. We are talking about a textbook science, undeniable reality, where the Earth literally built, turned on, and safely operated its own nuclear reactor. And it did this 2 billion years before humans ever learned how to split the atom.
So, let's set the scene. At a uranium processing plant in France, technicians were just running a totally routine quality check. They do this all the time. They measure the amount of uranium-235 in a batch of ore. And they do that because uranium-235 is the rare, highly unstable isotope that can actually sustain a nuclear chain reaction, the stuff we use to power cities or, build bombs. Now, here's the crazy thing about uranium-235. Everywhere on Earth, whether you dig it up in Canada, extract it from ocean water, or even pull it out of a meteorite that fell from space, it always makes up exactly 0.720% of natural uranium. Always. It is a cosmic constant. But the ore from this specific mine in Gabon, Africa, the Oklo mine, kept coming back at 0.717%. It was off by just 0.003%.
Now, I know what you're probably thinking. 0.003%, that's literally a rounding error. Who cares? But to a nuclear physicist, that is a massive, blaring red flag. See, when you take that microscopic discrepancy and multiply it across the entire massive deposit of ore in that mine, the math tells a terrifying story. That tiny percentage gap meant that roughly 200 kilograms of highly explosive, fissile uranium-235 was just gone. Completely missing. That is enough radioactive material to build half a dozen atomic bombs, and it had simply vanished from solid, ancient rock that no human being had ever laid eyes on. Naturally, the absolute first question the French authorities had to ask was, are we dealing with sabotage here? Was it theft? Could a rogue group have secretly mined this stuff to build unsanctioned weapons? Panic set in, and they launched a massive, top-secret investigation. But pretty much immediately they had to rule out human tampering. Every single geological and chemical tests they ran proved that this rock was completely natural. It was completely undisturbed. Absolutely no human had touched this uranium.
So, where did it go? Well, the chemical signatures locked inside the rock revealed a massive, incredible twist. When the scientists looked closer, they found very specific isotopes of elements like neodymium and ruthenium embedded right there in the ore. And that is huge, because those specific isotopes are the exact chemical ash that you only get after uranium has undergone a violent nuclear chain reaction. The uranium-235 wasn't stolen at all. It had been burned. This totally natural vein of ore had actually operated as a fully functioning nuclear reactor burning through its own fuel supply 2 billion years ago.
So let's look at Section 1. Impossible now, possible then.
Okay, I know exactly what's going through your head right now. A natural nuclear reactor? That sounds completely impossible. And you know what? You'd be right. You could not build a natural nuclear reactor by accident today if you tried. It's just not possible. To get a chain reaction going, you need a highly concentrated amount of uranium-235 packed closely together. Today, as we established, natural uranium is only at 0.72%, which is exactly why modern power plants spend billions of dollars using giant centrifuges to artificially enrich their fuel to about 3%. But here's the secret. Uranium-235 is highly radioactive, right? That means it decays much, much faster than its heavier, more stable cousin, uranium-238. So if we just rewind the clock 2 billion years, there was simply way more uranium-235 around. The Earth was naturally pre-enriched by time. Back then, the natural concentration of uranium-235 sat right at around 3.1%. That happens to be the exact magical threshold you need for reactor-grade foil.
And I really want to make this absolutely crucial point clear. This is not broken physics. This is not some anomaly that defies the laws of nature. This is physics. The Oklo reactor is entirely 100% explained by the relentless, predictable mathematics of radioactive decay playing out across a vast, almost unimaginable span of deep time. It is literally impossible to form naturally on Earth today, but the exact same physical laws made it completely, totally possible back then.
All right, moving to Section 2, the self-regulating pulse.
So this brings up a huge question. How exactly did a highly concentrated vein of reactor-grade uranium just switch itself on without instantly melting down into a giant crater? I mean, without a control room, without human engineers, without graphite control rods, how did nature keep this massive reaction from overheating, boiling, and just destroying itself immediately? Well, in nuclear physics, the answer is something called a moderator. It's basically a substance that slows down fast-moving neutrons just enough so they can actually hit and split other atoms to keep the chain reaction going. In our modern human-made reactors, we use highly engineered systems like heavy water or pure graphite to do this. But at Oklo, ordinary, everyday groundwater seeping through the porous sandstone rock acted as nature's totally ingenious control system. And the way this worked is just brilliant. It created a perfectly safe, self-regulating breathing cycle. It's like a giant puzzle with 3 repeating steps. Step 1. Groundwater naturally enters the dense uranium vein. It acts as a moderator, and boom, the nuclear chain reaction switches on. Step 2. That fission reaction generates intense, massive heat, which eventually boils the groundwater right away into steam. And without the liquid water there to moderate those neutrons, the chain reaction literally starves and safely shuts itself down. Step 3, the rock slowly cools off, the groundwater seeps back in, and the whole cycle starts over again. By studying trapped xenon gas in the rocks, scientists realized this thing actually pulsed. It turned on for roughly 30 minutes and then shut down to cool off for 2.5 hours. And it repeated that exact safe cycle for a staggering 150,000 years.
Which leads us perfectly into Section 3, Nature's Nuclear Waste Fault. Now, you might be wondering, why does a 2-billion-year-old rock anomaly matter to us today? Well, it's because Oklo serves as a real-world ancient experiment that actually solves one of our most brutal modern engineering headaches. Where on Earth do we safely store highly radioactive waste? See, when nature ran its reactor, it created the exact same highly toxic radioactive byproducts that our modern reactors do. Nasty stuff like plutonium, cesium, strontium, and iodine. But here is the truly incredible part. When scientists studied the Oklo site, they found that these highly hazardous materials had barely moved an inch. For 2 billion years, they remained safely trapped inside the surrounding aluminum phosphate minerals and clay, sitting just centimeters from where they originally formed. This is literally the ultimate, gold standard proof that deep geological storage for nuclear waste actually works over timescales we couldn't possibly hope to test in a laboratory.
And finally, Section 4, testing the universe's constants.
Okay, buckle up because this might be the wildest application of all. The Oklo mine actually provides modern physicists with a tool to test the stability of the universe itself. We are talking about probing the deepest, fundamental laws of reality using data saved on a 2-billion-year-old rock hard drive. To grasp this, we have to talk about something called the fine structure constant, usually represented by the Greek letter alpha. It is a fundamental, bedrock number in physics that controls how strongly atoms hold on to their electrons, and essentially how electromagnetism itself behaves in our universe. And a huge lingering question in modern physics is this: have the fundamental constants of the universe drifted or changed over the lifetime of the cosmos? Usually, we can only measure these things over the last century or so in our labs. Well, the answer to that massive cosmic question was hiding in an isotope called samarium-149. See, the exact way that these specific atoms absorbed neutrons 2 billion years ago depends entirely on the value of that fine structure constant at that specific moment in time. So by measuring the leftover isotopes in the Oklo rock, physicists were able to work backwards, and the result? They proved that the fine structure constant has barely changed, if it's even changed at all, across 2 billion years. Think about that. An accidental reactor made of dirt, rock, and groundwater is right now our best scientific witness for the stability of the universe itself. It all leads to a rather humbling realization, doesn't it? We didn't invent nuclear power in 1942. We just reinvented it. The Earth got there roughly 2 billion years first. When we think about our planet's deep past, it wasn't just some boring, blank slate of slime and empty rock. It was older, stranger, and far more inventive than our human instincts really let us feel. Nature was quietly running a completely safe, self-sustaining nuclear facility for 150,000 years, long before multicellular life even started crawling across the planet. It really makes you wonder, right? What else is buried deep down in the Earth, just waiting for a tiny, seemingly unimportant mathematical anomaly to give it away? If nature could build a fully functioning nuclear reactor entirely by accident 2 billion years ago, what other impossible technologies has the universe already mastered? If you found this explainer as fascinating as I did, and you want to keep exploring the universe's greatest mysteries through clear, visual storytelling, do me a favor and hit that subscribe button right now. We have so many more incredible science-backed true stories to uncover together. Thanks so much for joining me, and keep questioning what you think is impossible.